All right, so welcome back. Um, Today we're going to be continuing to work on this packet, and yeah. So the last time we did page 11 together, and then I told you guys to do pages 10 and 12. So, real quick, just looking over my answers to 10 and 12. I'm just gonna scroll through these pretty quickly. So, if you just wanted to look over your answers, here's what you should have had for 10. And then for number 12, we did number 2 on number 12 together. But yeah, the rest of these. And y'all were doing pretty fine at this. In the assignment you turned in, looked pretty good overall. I was quite pleased. So that was adding and subtracting. We've done multiplying and dividing. We've done simplifying. So today, what we're going to be doing is solving equations. So we know that we're doing multiplying or dividing because there will be. Did we do this one? I don't know. Okay, whatever. Yeah, we know that we're going to be doing multiplying or dividing because there's a multiplication sign or division sign in the actual equation. We know that it's simplification if there's only one fraction. We know that it is adding or subtracting if there's an addition sign or subtraction sign in the expression. We know that it is an equation, which is what we're looking at today. We know it's an equation well, if there's an equal sign, because our equations are always going to contain an equal sign. So, in equations, we are solving, and we're solving for x. I can't solve for x in a problem or in problems like these ones that we just did on page number 12 because there is no equals. It doesn't say like 7 over 3x minus 2/5 equals something. It has to equal something for me to be able to solve. But now we're getting into things with equal signs. So we're actually going to be solving these. And actually, page 13 only has 6 problems, but page 14 has 8 problems. So we're going to do page 14 together. Y'all are going to do page 13 on your own. So yeah, we're doing 14 together. So, solving equations. We don't know what operation they're going to throw at us. We don't know what's going to be going on with these equations. All we know is that we got to solve. So, looking at the first one, I see negative 4x over x minus 8 minus 11 over x minus 8 equals 25 over x minus 8. So, let's see. I'm going to bring this up here real quick, actually. I'm going to show you an example with, instead of x minus 8 as the denominator, let's say if I had negative 4x over, instead of x minus 8, let's just call x minus 8 5. We're saying minus 11 over 5 equals 25 over 5. So, all 3 of these fractions have the same denominator, which means I can basically just get rid of that denominator because if I multiply the left side of this equation and the right side of this equation by 5, so I'm going to multiply that by 5, I'm going to multiply that by 5, and then I have to distribute, and then distribute that in there. That just gets me negative 4x minus 11 equals 25, which is exactly what I would have had before if I just gotten rid of the denominators, because all the denominators are the same. I can't get rid of the denominators until they're all the same. So I have negative 4x minus 11 equals 25. And I'm going to have the exact same thing here, actually, because I have all 3 of my denominators, they're all x minus 8. So, since they're all the same denominator, I can just go ahead and get rid of them. So, I'm going to have negative 4x minus 11 equals 25. And now I have an equation that I can solve for x. And the denominators, I completely got rid of them. Not worried about them. So let's see. I'm going to start to solve this by adding 11 both sides. So I got negative 4x equals 36. And then divide both sides by negative 4. And I get x equals negative 9. So that is my solution. X equals negative 9 for this one. And if I plug that in, I will get, I'm not going to plug that in because, you know, I don't want to figure out what that, well, all of the denominators are going to be negative 17 because it's negative 9 minus 8. So yeah, it's just not going to be a pretty fraction, but it's going to be equivalent, whatever it is. So yeah, x is negative 9 here. But then let's look at number 2. This one, I can't do that same thing yet because I can't cancel out these denominators yet. I need to give all these the same denominator in order for me to cancel them out. And when we were doing the adding or subtracting these fractions, there were only 2 that we were working with, but now there are 3 that we're working with. But fortunately, it looks like all 3 of them could be turned into that 4x minus 24 denominator that there is. So let's see, the second fraction, that 2x over 4x minus 24, already has 4x minus 24 as its denominator. But 3/4, I need to change that denominator into the 4x minus 24. So let's see. To do so, I'm going to multiply it by x minus 6, I believe, yeah. Yeah. So let's see, because we want to get it to turn into 4x minus 24, and I have 4x minus 24. If I pull out the GCF, it's 4 parentheses x minus 6, which means that I have to multiply this 3/4 by x minus 6 over x minus 6. So I gotta multiply that by x minus 6. I gotta multiply this by x minus 6. And then I have this 8 over x minus 6. So this 8 over x minus 6 already has the x minus 6 part, but it doesn't have that 4 part. So I need to multiply this by 4 over 4. And this 2x over 4x minus 24, that already has the common denominator that we're looking for, so I don't need to do anything with that one. So yeah, that's what I'm going to be working with here. Let's see. Hold on. Okay. Sorry, just never mind. Okay. So I have this 3 times x minus 6 over 4 times x minus 6. I already know that 4 times x minus 6 is going to turn into that 4x minus 24. So I'm just going to go ahead and simplify that for myself. So I got over 4x minus 24. And I distribute that 3 to the x and to the negative 6. That gives me 3x minus 18. And then I have minus that 2x over 4x minus 24. 2x over 4x minus 24. And then equals, and then I have, so it is what? It is 8 times 4 over 4 times x minus 6, because I multiplied by 4 over 4. Distribute, and 8 times 4 is 32 over 4x minus 24. So now I have an equation, and all 3 fractions here have that same denominator, and I can just go ahead and solve it now. So I can get rid of the denominators now that it's like this, And once I do that, well, I'll actually just go straight across and erase my denominators. Okay, there. Yeah, we'll bring some things up. Okay, so I have 3x minus 18 minus 2x equals 32. So 3x minus 2x, I can combine my like terms on that left-hand side of the equation. 3x minus 2x is just going to be x. So I've got x minus 18 equals 32. And then add 18 to both sides. X equals 50. That's my solution. So yeah, for this problem, x equals 50. Yeah, that's all we got to do. And we'll keep going on. And I know that it may not make sense to you, like how I'm getting these common denominators, but it's okay. It will make sense. Things will start to make sense. Okay, so on this one, there is no, or none of them already has the common denominator because, let's see, I have 3 over 6x, and there's nothing I can multiply that by to get to 12 because I can't like multiply it by anything to get rid of that x, and I can't multiply by anything to get it to 4x. And then the 12, if I want to multiply that by something to get it to 6x, well, I would have to multiply by a fraction, and I'm not going to multiply by a fraction. So what I'm going to have to do is find a least common denominator. So on this problem, what do we got going on? I'm trying to think here. Okay. So yeah, 6, 12, and 4. The greatest common, or the least common multiple of these three numbers is going to be 12, because 6 I can multiply by something to get to 12. 12 I can multiply by 1 to get to 12. 4 I can multiply by something to get to 12. And then two of these fractions have an x in them, one of them doesn't, which means I have to put an x into the one that doesn't. So let's see, to get this 3 over 6x to something over 12x, I'm going to have to multiply it by 2 over 2. This 12 already has the 12 that I want, but it needs the x. So I'm going to have to multiply by x over x. And then, let's see, this 11 over 4x, I want to get that to something over 12x, so I'm going to have to multiply that by 3 over 3, because 4 times 3 is 12, and yeah, and then I can just do that. So when I multiply these together, let's see, I have 2 times 3 is 6 over 12x minus, and then I have 9 times x is 9x over 12x equals, and then I had 11 times 3, which is 33, over, well, 4x times 3 is 12x. And now all three of these have the same denominator, so I can get rid of that denominator. So if I do that, that gives me just 6 minus 9x equals 33. And my next step, what am I going to do? I'm going to subtract 6 from both sides. So that's going to give me negative 9x equals 27. Divide by negative 9, and x equals negative 3 here. All right, cool. So on that problem, x equals negative 3. And yeah, it's just like finding what we need to multiply everything by to get it to the least common multiple. And finding the least common multiple, especially when there's like an x in it, I'm not really sure if there's like a trick to doing it. It's just like being able to look at it and say like, oh, like, well, for this next one here, like, I see that this 5x plus 10, that could turn into 5 times x plus 2. And then my other denominators, I have a 5 and an x plus 2, so that could work. So, yeah, let's just get into this one then. Let's see, I have 5x plus 10, and as I said, that one can turn into 5 times x plus 2. This 4 over 5, I need to get that to turn into 5 times x plus 2 as well. So let's see, I'm going to have to multiply it by x plus 2 over x plus 2. And this negative 6 over x plus 2, I want to get this to turn into 5 times x plus 2 as well. So that means I have to multiply 5 over 5. So, and the first fraction I didn't have to do anything with. And when I do that, I'm going to have everything is going to turn into 5 times x plus 2, or just 5x plus 10. Actually, hold on a second. Yeah, on this sheet that I was going to have you do beforehand, like looking at numbers 5 and 6 here, like they don't even distribute that back out. They just leave it as 5 times x plus 6 or 7 times x minus 3. So yeah, you don't have to distribute that back out sometimes. But it looks like you do in this case. So, if I distribute that out, well, my first fraction is 18 over 5x plus 10. And then I have plus 4 times x plus 2. So 4 times x is 4x. 4 times 2 is 8. So 4 times x, I said it was 4x. 4 times 2 was 8. Over, and then 5 times x plus 2 is 5x plus 10. Equals, and then I have, let's see, negative 6 times 5 is negative 30. And 5 times x plus 2, hopefully we know by now that that is going to be 5x plus 10. So now that all three of the denominators are the same denominator, I can get rid of the denominators. So that's going to give me 18 plus 4x plus 8 equals negative 30. I'm going to combine like terms on the left side of the equation. So I have 18 plus 8 is 26. Yeah, it's 26. So I got 4x plus 26 equals negative 30. Subtract 26 from both sides. I'm going to move this up a little bit. I think I overestimated how much room I had left. Okay. So yeah, subtract 26 from both sides. That will give me 4x equals negative 56. And divide both sides by 4. We'll come over here. X equals, is that negative 14, I believe? Yeah, negative 14. Yes. So negative 14. X equals negative 14 on this problem. And yeah, that's all we have to do. Find that common denominator. So this one, as well as number 8, both have a quadratic in the denominator. And I'm just going to kind of assume that that quadratic, well, okay. They're not going to give you a problem that's like super weird and hard, and you're going to have to give it like extra factors. So I'm just telling you straight off the bat that x squared plus 5x plus 6 is x plus 3 times x plus 2. And same here for number 8. X minus 6 times x plus 2 is x squared minus 4x minus 12. So this first fraction, that 12 over x squared plus 5x plus 6, already has our common denominator. So I'm just going to rewrite that. 12 over x squared plus 5x plus 6. And then I said that this was x plus 3 times x plus 2. So this second fraction already has the x plus 3. Now it needs the x plus 2. X plus 2. And this third fraction already has the x plus 2, but now it needs the x plus 3. Okay, so we will figure that out. I already know what my denominator is going to be. It's going to be this x squared plus 5x plus 6. And then I just need to distribute these. So I got 7 times x and then 7 times 2. So plus 7 times x, 7x, and 7 times 2 is 14 over that x squared plus 5x plus 6. Equals, and then let's see, I have that 2 times the x and the 2 times the 3. So it's going to be 2x plus 6 over x squared plus 5x plus 6. And now they all have the same denominator, so I can get rid of that denominator. So they all have x squared plus 5x plus 6 as their denominators, and I'm just going to rewrite this without the denominator. So 12 plus 7x plus 14 equals 2x plus 6. And that's just the same equation, just without the denominators now. Let's see, I'm going to combine my like terms. So I have my 12 plus my 14, 7x plus 26 equals 2x plus 6. I will subtract 26 from both sides. That's going to give me 7x equals 2x minus 20. And then I will subtract 2x from both sides over here. Yeah, so I subtract 2x from both sides, and that is going to give me 5x equals negative 20. Divide by 5, x equals negative 4. So yeah, the solution to this one was negative 4. I know that they're all turning out to be negative numbers. Whatever, I can't change that. I didn't know they were all going to work out to be negative numbers. Maybe they aren't. Well, that 50 was a positive, but whatever. So yeah, let's just get on to the next one. X equals negative 4 for that one. And again, we can only solve for x when there's an equal sign. If you see a problem like the ones we were doing last week, you can't solve for x because there is no equal sign. So don't try to solve for x if you see something like that. It's just like recognizing, oh, what am I doing here? And then being able to actually perform that. So here, on number 6, I have 10, I have 5x, and I have 2x. So this one is just going to be pretty much the same as number, 3 there. So the 5x, the 10, and the 2x should all be turned into 10x, because 5x, I can multiply that by 2 to get to 10x. 2x, I can multiply that by 5 to get to 10x. And 10, I can multiply that by x to get to 10x. So I'm going to do that. I'm going to multiply that times x and times x. I'm going to multiply this times 2 and times 2. That's not a squared, that's a 2. And I'm going to multiply this times 5 times 5. So when I do that, let's see, 1x is just x over 10x plus, well, 4 times x times 2 is going to be 8x. And then 5 times x times 2 is going to be 10x. And then let's see, equals negative 9 times 5, which is negative 45. And then 2x times 5 is going to be 10x. So my new equation is x over 10x plus 8x over 10x equals negative 45 over 10x. And now they're all the same denominator, I'm just going to get rid of the denominator. So I got x plus 8x equals negative 45. I can combine my like terms. I got 1x plus 8x is 9x, and that's equal to negative 45. And then divide both sides by 9, x equals negative 5 on this problem. And that's my final answer. It's a nice color I want to go with. I'll go with orange. Okay. So yeah, x equals negative 5 on this one. Just solving. And we're going to do these last two together as well. And then you'll be doing these on your own. Okay, number 7. Hopefully you're looking at this and you see that this is super easy because they all already have the same denominator. The denominator on all three of these is 2x minus 5, so I don't have to do a single thing to this. I just have to get rid of the denominators now because I have 2x minus 5 for all of them. So that's just going to be 14 plus 7x equals 63 when I get rid of the denominators. And now, let's see, I will subtract 14 from both sides. Don't even have like terms to combine. So if I subtract 14, that gives me 7x equals 49. And then divide by 7, so x equals 7. That was super easy to solve. Yeah. So that one, yeah, super easy to solve. I didn't have to do anything with the denominators because they were all already the same denominator. Okay, and then we have number 8. Number 8 is going to be similar to number 5, where it was like kind of ugly, but you know, not bad. Okay, so like I said, this one we're going to have x minus 6 times x plus 2 is x squared minus 4x minus 12. And that means I have to get this 2 over x minus 6 to turn into something over x minus 6 times x plus 2. So since it doesn't have the x plus 2, I just need to multiply it by that x plus 2. I need to multiply this by that x plus 2. And same with this 7 over x plus 2. That is missing the x minus 6 aspect. So I'm going to have that x minus 6 multiplied by both the numerator and denominator there. So, and then I have the 4x plus 2 over x squared minus 4x minus 12. I don't have to do anything with that one. It already has the denominator we're looking for. And you might be confused on like how I knew that it multiplies out. It's just from years of being a math major, math expert, looking at this and knowing that, oh, that's going to multiply to be that. So, you know, yeah. Yeah, let's just do the operation. So if I multiply this out, or if I distribute this out, I got 2 times x and then 2 times 2. So that gives me 2x plus 4 over, let's see, and then I have that common denominator of x squared minus 4x minus 12. And then I have this 7 times x minus 6. I multiply 7 times x and 7 times negative 6. So plus 7x minus, and then 7 times 6 is 42. And that still has the same denominator. Okay, and then the third fraction just stays the same. It's still just 4x, nope, not plus 12, it's plus 2, over x squared minus 4x minus 12. And now I have this expression. All of them have the same denominator, so I'm getting rid of the denominator. And that's going to give me 2x plus 4 plus 7x minus 42 equals 4x plus 2. And I'm going to, well, first thing first, I'm going to combine like terms. So I have 2x plus 7x is going to be 9x. And then I have 4 minus 42 is going to be negative 38 equals 4x plus 2. Let's see. Next thing I'll do here is I'll add 38 to both sides. So that's going to be 9x equals 4x plus 40. And then I'm going to subtract 4x from both sides. Subtract 4x gives me 5x equals 40. And then divide by 5. X equals 8. So yeah, perfect. X equals 8 on that one. So yeah, all you have to do, find the denominator, figure out what the common denominator is, and then put these fractions over that common denominator. You cannot get rid of the denominators until they are all over the exact same denominator. So like I said, I do want you guys doing number 13. And it's only 6 problems, shouldn't be too bad. And like numbers 5 and 6, they're not even like distributed all the way, so it shouldn't be too bad. Numbers 1 and 2, you don't even have to like change any denominators or anything. It's just like go straight across, get rid of the denominators from the get-go, because they're all the same denominators. And then, let's see. I think I would like for you what would I like for you to do? Okay, we're not going to worry about page number 15. So I'll put a big X through that. I'll make it bigger. Yeah, we're not worrying about page number 15. Don't worry about page number 15. But 16 and 17, I would like you guys to do as well. And these are review. So like 16, this is subtraction, addition. And then 7 and 8 here on page 16, this is like the new thing with like solving for x. And we can tell because there's an equal sign. And on problems 1 through 6 on page 16, there is no equal sign. So we're not solving for anything, we're just simplifying. We just got to do what you did last lesson. But, you know, here you are simplifying. And 17 is the same thing. You simplify these first 3. These are 4 through 6. 2 of them are multiplication, 1 is division, so you should know how to do that. 7 and 8 are addition and subtraction, simplifying the expressions. And then 9 and 10, you're solving for the variable. You're solving for x. Is that the same problem? It is. Whatever. Okay. So yeah, that is what y'all are going to be working on. Pages 13, 16, and 17. And that is the end of this packet. I think all we have left for this unit is, well, I mean, there's like a couple things that I do want to touch on for this unit, but I think we've covered the basics. We've covered the meat of the unit, really. There's not much else we have to learn. And we'll be doing some graphing rational expressions at some point, probably by the end of the week. But yeah, I will post another one of those assessments for pages 13, 16, and 17. So get those done. Bye.